Hi, so today I want to work on writing variable expressions with 2 or 3 operations on IXL. So before we start with the IXL problems, I want to just review order of operations and why it matters. So order of operations, we often use this acronym PEMDAS to help us remember which order to do operations in. So we always start with parentheses. So whatever is in a parentheses, whether it be addition, subtraction, multiplication, exponents, whatever combination of numbers that we have in parentheses are always done first. And then with exponents are done next. Multiplication or division can be done in either order, but multiplication and division must happen before you can do addition or subtraction. And addition and subtraction can be done from left to right. So always start with the left and move to the right. I'll give you a quick example. Once again, this is all just review. So for example, if I have this problem, 3 plus 4 to the power of 2 plus 5. To solve this, I don't have any parentheses, so I would start with the exponents. So I would do 3 plus 4 to the power of 2 is 16 plus 5, and then I would add that all together from left to right. So I would do 3 plus 16 is going to be 19 plus 5, I'm getting 24. So the answer to this problem is 24. Now if I took the exact same problem, but I just did 3 plus 4 in parentheses to the power of 2 plus 5, so you see that it's actually very similar to the one that we started with, but now I have parentheses in here. It's actually going to change the value of your end problem. It's going to change the end result because you'll do the parentheses first. So if I solve the parentheses first, I have 7. 3 plus 4 equals 7, so I'm going to have 7 to the power of 2 plus 5. 7 to the power of 2 is 7 times 7, that's 49. Now we're going to add 5 to that. 49 plus 5 is 54. So you see we actually get different answers just by adding the parentheses in there. So that's why order of operations matters. Now with the right variable expressions, we're not actually solving for variable expressions, but we're setting them up. Usually with variables, which means unknown numbers, which means that we won't be able to solve them yet. So let me give you an example. If I took that exact same setup that we just did, but let's say instead of 3 plus 4, I had 3 plus a to the power of 2 plus 5. Now I can't solve it because a stands for an unknown number. That number might be 4, it might be 15 or 25 or negative 100, or it maybe depends. That's why it's called a variable. The value of that letter could actually, that unknown number could actually vary. So it's a variable. So I can't solve for it, but this is a very different expression than this, because in the first one I would be doing 3 plus a and putting it to the second power and then adding 5, and in this one I would be solving for a to the power of 2 and then adding 3 and adding 5. So you're actually going to get a different answer. So that's why it matters that we use PEMDAS, order of operations, be aware of parentheses, and think about how somebody would have to go through the problem in order to have that variable expression. So let's go back to the IXL problem. Write an expression for the sequence of operations described below. Raise w to the 5th power, then add 9 to the result. So w to the 5th power, to do the exponents, you'll use this button with kind of the big square and then the little square in the corner. So I'm going to do w, then I'm going to click that button. You see it kind of puts a little square up in the right corner, and I'll put in the 5. Now I'm going to click it again to let it know that I'm done doing the exponents. So I've got w to the 5th power, and now I'm going to add 9 to the results. So I'll do plus 9. Now I know that this is correct, no parentheses needed, because this exponents are always done first according to the rules of PEMDAS. And so the w to the 5th power will be done first, and then 9 will be added to it. It follows. So now it says raise 9 to the 10th power, then find the difference of the result in D. Whew, all right, so let's start with raising 9 to the 10th power. I'm going to put in 9, I'm going to click that exponent button, put in the 10, click that again, so I've got 9 to the 10th power. But now I'm going to have to find the difference of the result of that and Z. So the difference between the result of that and D is going to be that minus Z. Awesome. What is 5 divided by the product of 4 and n? Now remember, a product is what you get when you multiply two things. So we want 5 divided by 4 times n. On the IXL program, to do division, you're going to use that fraction looking button, because remember, fractions are division problems. So we're going to do 5 on the top and then divided by 4 times n. And so we can write that a couple of different ways. With numbers and variables, you can always just write the number and the variable, 4n. That implies that you're multiplying the two. You can also use this little dot, 4 times n. You actually don't need parentheses here, because remember that multiplication and division, you can do them in any order, so no parentheses are needed. Awesome. So now we need 8 more than the sum of t and u. So here we're definitely going to need some parentheses. And the reason why is because the sum of t and u are going to be one part, and then we're going to need 8 more than that part. So we're going to do 8 plus, put in the parentheses, so you're going to use that button, t plus u. So the sum of t and u is t plus u, and you're adding 8 more than that. Okay, multiply the sum of 8 and s by 3. Once again, we're definitely going to need parentheses, because that sum times 3 is going to be different than 3 times just one part of that sum. So there's a bunch of different ways we can do this. Let's just start with the sum of 8 and s. 8 plus s, and then we'll multiply that by 3. I could also write 3 in front of the parentheses and have it just say 3 parentheses 8 plus s. That implies multiplication, and that would also be correct. You can write it either way. Raise the quotient of b and a to the 10th power. Quotient, remember, is the result of a division problem. It's called a quotient. So the quotient of b and a to the 10th power. So I'm actually going to put this in parentheses. So I click the parentheses button, and then I'm putting the quotient, the fraction division problem, within the parentheses. That wasn't correct. Okay. Just so it's clear that I'm not putting just b to the power of 10 or just a to the power of 10, I put b over a in parentheses, just so it's clear that that whole thing is what I'm putting to the power of 10. And then I'm clicking the exponent button and putting in the 10. So that whole thing is to the power of 10, not just one part. If I had written just b a to the power, yeah, that wouldn't have worked. So I put that in parentheses and then put it to the power of 10. Multiply q by the difference of s and r. Once again, definitely going to need parentheses because we need the difference of s and r. So that's going to be s minus r. The difference is another way of saying subtraction, so S minus R is the difference, and then we're going to multiply that whole thing by Q. So we put it in parentheses so that we know we're not just multiplying a part of it. There we go. Triple the product of S and P. So the product, remember, is multiplication. So we'll put S and P, the product, we want that whole thing tripled, not just part of it. So we'll put that in parentheses. I'm going to just write 6P, and if I put 3 in front of it, then I have 3 times 6P. I could also write that using using the dot as the operation, so I could do 3 times 6 times P, and that's the same exact thing. This is the same as just leaving all of the dots out and just letting multiplication be implied. Raise C to the 9th power, then double the results. So it's important once again that we remember, if I just wrote 2C to the 9th power, then the person doing this operation would wonder whether that 9, that exponent of 9, only applies to the C or also applies to the 2. We need it to apply to both the 2 and the C. So we're going to put 2C in parentheses. Oop. Let's take away that. We're going to put 2C. Oh, I'm sorry, I'm reading this wrong. Raise C to the 9th power, then double the result. Yeah, so actually that's correct. You can just do 2 times C to the 9th power. If I had put 2C in parentheses, as I was just about to do, then it would mean that both 2 and C, the product of them, would be raised to the 9th power. Awesome. So I'm going to give you a chance to try